The next that we're going to be looking at, the next gas law, will be what we call the combined gas law. And the combined gas law is going to take Charles and Boyle's and Guy-Lussac's law and put them all together. So instead of having to have the pressure constant or the volume constant or the temperature constant, the only thing that we have to have constant is the number of gas particles. But we can change the pressure, the volume, or the temperature with this equation, and this allows us to be able to do more calculations, and instead of having to remember three individual gentlemen's gas laws, we can just remember this one combined gas law. So if you wanted to use this one, for instance, with the one Guy-Lussac's problem, it said if volume does not change. If volume doesn't change, then just that's canceled out, like it's gone. So then you just have pressure over temperature equals pressure over temperature. So that's really helpful, just decreases the amount of memorizing that you need to do. So what we're going to do in this problem is we're going to practice solving, and all we're doing is increasing the amount of numbers in the problem. We still don't do anything different as far as how we solve the equation. So the volume of a gas is filled at 30.0 liters, and it has a temperature of 318 Kelvin. We do need temperature to be in Kelvin still. And it has 153 kilopascals for its pressure. Now we want to know what the volume would be at standard temperature and pressure. So it's important that we remember what our standard temperature and pressure are, because we're only allowed to have one unknown that we can solve for. And right now, in our combined law, we have a total of 6 2 pressures, 2 temperatures, and 2 volumes. And so we need to have only one of the 6 can be unknown. And right now that is the volume. What would the volume be? So that is our unknown. We know our first pressure is 153 kilopascals. The first volume, the balloon's originally at 30.0 liters, and our temperature is already in kelvins, 318 Kelvin. Now, for standard temperature and pressure, pressure can be one of two things. It can either be 101.3 kilopascals or 1 atmosphere. We're going to want to use kilopascals since the first pressure is already in kilopascals. And the temperature could be 0 degrees Celsius or 273 Kelvin, and since we want Kelvin, we're going to use the 273. So that goes way back many units ago when we first looked at standard temperature and pressure. We're going to use pressure 1 times volume 1 over temperature 1, and that is equal to pressure 2 times volume 2 over temperature 2. Plugging all of these numbers in, it's really important here that you show good handwriting, because having this many numbers in units all squished together sometimes is a nightmare to find if your handwriting is difficult to see. So make sure that you're very careful and that you are showing all the numbers and the units and keeping things very clear. Volume is what we don't know, so I'm going to leave that as V2. And I have 273 Kelvin. So this is my initial starting point. Now you have to show me the equation you're going to use. You have to plug in all the numbers and units. And then from there, if you just wanted to give me your final answer with the correct unit, that would be perfectly fine. But if you wanted to go through the steps on showing the work and cross multiplying and dividing, you're more than welcome to do that. I will for this problem, just so that you can see it all written out, but I do want to cross multiply to get volume out of this division bar that I have right here. So I'm going to take 153 kilopascals times my 30.0 liters and multiply that by 273 Kelvin. So I'm just taking these 3 items that I'm cross multiplying together, and then my other cross multiply is 318 Kelvin times 101.3 kilopascals times volume 2. So I've taken and I just have this more linear now, and I want volume by itself. And if you wanted to multiply these 3 numbers and just get one number, and multiply the 318 and the 101.3 and get one number, you're more than welcome to do that. Just the least amount of things that I can write down will just save me time. So I don't want to do a lot of calculating because that means I have to round, and I would prefer not to round except for just the one time at the end, or you and I are going to get different numbers. So please make sure that you are really careful and you don't round too much along the way, or your numbers and my numbers will not add up. So again, what I do to one side I have to do to the other. So I'm dividing by the 101.3 kilopascals, I'm dividing by the 318 Kelvin, so that they will all cancel, the units and the numbers are gone, and that leaves me with 153 times 30 times 273 divided by 318, and then divide by 101.3. And if you've plugged that into your calculator, before you write down a number, make sure you know significant digits. Each one of these has 3 except for the 101.3 has 4 significant digits. So we have to go with the least amount, which is 3, and that would be 38.9. And the volume, we should know that volume is in liters, but just to double check, we have Kelvin on the top and bottom, it cancels, kilopascals on the top and the bottom, so it cancels, and it does leave us with just liters as the only unit we have not gotten rid of. If we do one more of these, we have a gas at 155 kilopascals and 25 degrees Celsius. It has an initial volume of 1.00 liters. All of that is our starting point, our first pressure, our first temperature, our first volume. So I'm going to get those written in. Our pressure is 155 kilopascals. Temperature has to be in Kelvin, so 25 degrees Celsius plus 273, 298 Kelvin, and 1.00 liters. Now the pressure of the gas is allowed to increase, so our second pressure after it has increased is now 605 kilopascals, and the temperature is allowed to raise all the way up to 125 degrees Celsius. Again, not allowed to have Celsius, so 125 plus 273 gives us 398 Kelvin, and we want to know what our new volume is. So that's our unknown, volume 2. I need to see from you the equation that you're choosing to use. That should be a 1. So I would expect to see the equation and at least the numbers plugged in to the equation. So you could, or you should be, writing all of this in so far with me. And on the other side, our pressure was 605 kilopascals. The volume was unknown. You could leave that as an X if you wanted to. Temperature was 398 Kelvin. Now from there, that's all you would have to show. If you just want to say volume 2 equals this number and unit, you would be perfectly fine in doing so. But if you cross multiply, you're going to take 155 times 1 times 398, and you're going to divide the 298, and you're going to divide 605, and then V2 would be by itself. Now if you do all of that, your units and everything are going to cancel except for the volume unit, because you notice you have kilopascals and kelvins on both sides, so they're going to cancel, and liters is the only unit that doesn't have anything to cancel with it. So liters is our volume unit, and everything has 3 significant digits this time, so we need to stick with 3, and 0.342 liters should be your final answer.